All right, we're going to start a new unit, which is one variable statistics. And for today's lesson, we're going to identify, describe data of one variable statistics. So first we're going to start out, there's a lot of vocab here. So the first thing we're going to start out with types of variables. So you have categorical or category, think of it that way. Those are variables that involve characteristics of an individual. They are not numerical in nature usually. So an example would be favorite ice cream, types of pets, favorite school subject, math obviously. And then the next type would be quantitative, and that's variables that measure some aspect of the variable. So it involves numbers that we can perform calculations with. So quantity, that's how I think of that. And examples would be quiz grades, number of siblings, height of students in the class. So those are types of variables. Now we have types of graphs, and they all represent quantitative data. So these are all things that you can measure. So the first thing is a dot plot. A dot plot has one horizontal axis, so that's this right here, and it's labeled quantitatively. So 5, 6, 7, all your numbers here, and those are the number of hours slept. And a dot to represent each individual in the sample. So if you notice, it's number of hours slept. So we had one person, since we have one dot, that slept 5 hours, one person slept 6 hours. We have 3 that slept 7, and you have 8 that slept 8 hours, and then so on and so forth, where you have 2 people that slept 11 hours. So this is representing, each dot represents one number of hours slept. All right, the next one is a histogram. So histogram, they have 2 axes, the horizontal, which represents the variable being measured, and the vertical, which represents frequency or percent. So the bars should all have the same width. So we should all be the same width here. I'm not going to have all different lengths. And then this is important too. The bar includes the number on the left, but not the number on the right. So this portion all goes with 20. This portion all goes with 30. So just be careful when you're reading that. And then the frequency is how often it happens. That's here. All right, and age is across the x-axis, or this horizontal. Then you have a box plot. So a box plot uses the 5-number summary. We'll talk about that a little bit later. Most have 2 whiskers, so these are considered your whiskers, on either side, and a middle section with 2 parts. And again, we'll go over this a little bit more later. But it's a box with whiskers, so that's why it's called a box plot, or box and whiskers. All right, now we have shapes of distributions. So the shape of a distribution of data can be described using several terms. So we can say it's roughly symmetric, we can say it's skewed left, skewed right, and uniform. So all of these are all ways to describe how data is distributed. So let's go ahead, let's look here at some examples. If it's roughly symmetric, that means the data is roughly symmetric in nature, meaning it's pretty even on both sides of your bell curve or of your curve. So here it's pretty close to being about the same on this side as it is on that side. Skewed left. Now this is important because it means most of the data is on the right and there's a tail on the left. So we're going to look at the tail, and that's how you know what direction you're skewed. So there's an extreme low value in the data set. So an example of the data that's skewed left would be a really easy test where most people get A's or do very well. So this would be an example. If a lot of people got really good grades, it would be skewed because we're looking here at where the tail is. So that's why this is skewed left, because it's the tail. Skewed right means most of the data is on the left and there's a tail on the right. So again, the tail's right here. So before we had the tail here where most of the data was here. And then here we have the tail and most of the data is here. So an extreme value in the data set. So an example of data that's skewed right would be a really hard test where a lot of people didn't do very well. Uniform describes distribution that's roughly the same height across the entire graph. So if we were to look, they're all about the same height. So it's uniform as far as distribution. So that would be like you had the same amount of people that got all the grades, all the different grades. All right. Now, measures of central tendency. So there's center of data described by the mean or the median. The best measure of center is the one that represents the typical data value of the set. So the mean is the arithmetic average of all the values in the data set. So mu is the mean of the population, and then that symbol means the mean of the sample. So to find the mean, you add all of the numbers and then divide by the number of data values. So to find the mean, you take 2 plus 2 plus 3 plus 7. And we have 1, 2, 3, 4. So since we have 4 options, that's why we divided by 4. And the mean would be 3.5. The median is the middle value of the set of numbers. So to find the median, you put them in order from smallest to largest. If there's an odd number, that's the easy one. You just use the middle number. So example 2, 7, and 15. 7 is the middle because it's odd number, so it's easy to find the middle. But if it's even, what you have to do is you have to take average of the 2 middle numbers. So first we ordered them, and now we have an even, so we have to take the 2 middle numbers and we have to find the average, which would be 3.5. The mode is the number that occurs most often. You can have more than one mode or sometimes no mode at all. And in this case, with our sets of data, we don't have any modes because we don't have a number occurring more than once. Now, what's important to know is some effects by adding a data point. Your mean can be a significant change with any extremes, either high or low, and then it increases with the addition of a high value, and it decreases with the addition of a low value, which makes sense. And then median, there's usually very little change. So example, shoe sizes of the students in the classroom are all here. So we've got 5, 5, 5, 6, 6, 6.5, and 8. Johnny joined the class and his shoe size is 12. What effect will this have on the data? Now, Johnny's shoe size is way larger than everybody else in the class. So since that's an addition of a very high value set, it's going to shift everything up. So as an example, I found the mean by adding all of those together and then dividing by 1, 2, 3, 4, 5, 6, 7. So I added all those together, divided by 7, and I got 5.9. The median is just the middle, which would be 6. And then the mode is the number that shows up the most. So that's all I did there. Now, another way to look at this is you can actually do this on Desmos. So you can go to functions. So once you hit this box, go to functions down here, and you're going to go to mean. And within there, you're going to enter in all your values. So once you enter in all your values, it'll give you the number that you need. And then you can go back, and if you notice, that's exactly what we had here. We just rounded. And then the same thing with the median. We just go, click a new box, do median, and then once you've got your values, and then press enter, and it'll give you that value. So that's how you would do it on Desmos. Now we want to figure out what effect will size 12 with Johnny, what will happen there. So again, you're going to take all the data, and you can add each one of these up. And then this time you're going to divide by 5, 6, 7, 8. So you would divide, after you add all these together, you would divide by 8, and you would get 6.7. The median's still going to be about the same because it's going to be 6. It's still in the middle. And the mode should be the same too because we had the most number 5s before. But again, if you were to do this on Desmos. We already said those two. So these were the before Johnny. Now again, if I'm to add Johnny to the mix and add 12, now let's watch what happens. So before we had this, but now with the mean, we're going to have 6.6875. And then for the median, before we had 6, but now we're going to have, oh, remember we said the only difference was we just added 12, so we still had the same number, oops, that we had here. And 12 doesn't affect anything. So the example 2 is a small school employs 5 teachers who make between $40,000 and $70,000 per year. The newest teacher, Valerie, decides to teach part-time, which decreases her salary from $40,000 to $20,000. The rest of the salaries stay the same. How will decreasing Valerie's salary affect the mean and the median? Well, remember, the mean will decrease with the addition of low data. So since she decreased, and we're going down in value, we know that this is going to go down in value also. So the median stays the same. That's your middle number. And then right here, so whatever your median is will stay the same. And your mean will decrease because we went lower in value. That was a lot of vocab. Yep, that was it. Oops, wrong way. Okay, that was a lot of vocab for today. So just make sure you understand the types of variables, the different types of graphs, and then how to find, or the shapes of distribution, and how to find the measures of central tendency, which is your mean, median, and mode.